So yeah, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 61 and today we are going to solve LeetCode problem 142 linked list cycle 2. So it's quite similar to the previous one, but there is a twist in this question and it's a medium layer problem. So let's see the problem statement first. So given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. Fine. There is a cycle in a linked list if there is some other node in the linked list that can be reached against by continuously following the next pointer. Fine. Internally, pos is the used to denote the index of the node that tells next pointer is connected to 0th index. Understood? So it is -1 if there is no cycle. Fine. Note that the position is not passed as a parameter. Fine. So we are only just getting the list node ahead of the list node. Fine. Do not modify the existing linked list. Fine. So in example 1 we can see like it's quite similar to the previous question in which we just have to find whether there is any cycle or not, right? In that we have to return true or false, but here we have to tell the exact position, like where the cycle is basically starting, so starting part of the cycle, right? So in example 1 we can see head is likely list is given 3 2 0 and -4, and here we can see it is starting as position 1, so we will return the position 1, right? Or like we have to return the linked list that node itself. If there is no cycle, return the node, right? So in this case it will return the second node itself. Fine. So example 2 we have seen like from 1 the cycling starts, so we have in the output we are returning node 1. And example 3 as position -1, that is no cycle, but anyways we don't have access of this position, so we can't directly tell. So here we can return null in this case, because in case of no cycle we have to return null. Fine. So it's quite similar, I think. Like first we have to check whether there is any cycle or not. In case if there is no cycle, then we'll simply return null, but in case of there is some cycle, then we have to find that a starting node, right? So okay, let's start. So well, next, that's what all we need. I'll remove this one. So what we'll do, we'll again use that slow and faster like 2-point approach here as well. So let's create list node slow equals to our head. We are like have to create like our separate linked list, because we don't we can't like modify our existing list node, right? Fine. So I have taken 2-pointer slow and fast. Now what we'll do, we'll run a loop here and we'll check if fast is not equals to null, and fast dot next should also not equals to null. Okay, fine. Now like similar logic, slow will runs slow dot next one time, and fast pointer will run fast dot next like twice. So this is how our logic is. Now here we will simply check if slow is equals to fast, that means like there is a cyclic in this node, right? So what we can do, we'll simply do break here. We'll just come out of this loop, that's it. Let's suppose we have pointer at 2, and again we have got pointer got matched at the same place. We'll just break at that time. We'll not going to execute further. Fine. Now we'll check after the loop. Let me close this idea. So now after coming out of the loop, we'll have to check on condition. So fast should not equals to null, because maybe like that time both faster and slower becomes at the end, right? So anyways, we have to track the faster one, and fast dot next should also not equals to null. If it is so, so what will check if faster is equals to null or faster dot next is equals to null. That means we have already reached at the next one, and we will simply return null here. That means no cyclic was there, right? Okay, so yeah, both conditions can't be satisfied, so yeah, basically we have to do all condition. Any of them should comes to, then that means we don't have any cyclic that reaches end, so we'll simply return null, right? Basically here in third case, fine. So this case is handled, as we have already got the cyclic or not using this. Now what we'll do, if this case doesn't matter, doesn't exist, means then what we'll do, we'll update our pointer status of faster one. Slower will remain as it is in this place where they got passed. We'll make our faster node against to the head one, like a starting or a dot. And now what we will do, we'll simply check if fast is not equals to slow, then we'll just move fast with one as well. So here faster will also just move one time, similar as to slower one. So we'll also move slow to next. So whatever next point it's going to meet, that will be the entry point of the cyclic linked list, right? That's how we'll find, and at last we'll simply return slow pointer. Whenever it got matched, we'll return slow pointer. Even we can return fast, no matter what, right? Both will be in the same place when it is going to match. So that will be our answer. Let's submit and see. Fine. Okay, so our all three test cases got passed. Fine. Let's submit and see other test cases as well. Okay, cool. So it accepted all 18 test cases and it's bit 100%. That's quite good. Okay, so now if we talk about the time complexity here, so I'm using a constant space for the pointer, so it will be big of 1 space complexity, and time complexity, anyways we are iterating over each element once, so it will be big of n. Fine. So there are another approach we can use. If you know any better approach other than this two pointer like slow and faster, just comment it down. So for today that's all, and let's see you next video.